Hi, I'm just going to use this video to talk about the design of our roof. It's specifically related to our test house, so not the main house. I don't want to focus really on how we built it, but really just on the design itself. We've done other videos that deal with the construction, which you'll see linked below, and that goes into the actual build of it quite a bit quite a bit later. So in talking about the roof, it's worth looking at the design of the house to see how we arrived at different aspects of the roof design. So initially, this is the site before we started that we used for our test house. It's quite a narrow plot here, pretty flat. It's around quite a lot of dead trees around. There's an old broken up stone wall on one side, which is the south facing side. On the north side, there's a little slope going up and then just into the natural forest. So it's quite limited access. You can really only access from the front and back of the site from that side. There's no real side access there. So the first thing we did was build a foundation for the house. We went down about 3 feet to get below the frost layer, and then we filled that with some insulation foam and also concrete, not concrete, with some stone for the foundation from that side. Then on one side, so on the north facing wall, we decided to use straw bale construction. So initially there was of course a short stem wall just using concrete blocks, and then the straw bales on top of that. We were going to use a technique known as Nebraska style, which means that we didn't have any support structure for the building, just using straw on one side, straw bales on one side, and then cob on the other 3 sides, and then the roof would be resting directly on top of that. As we continued building the straw bale wall, we discovered that it wasn't really sort of stable enough for our liking, and for various reasons, we decided to move on from that and go on to a post frame structure around the whole building. So this is the wall just a little bit higher up, and the first initial trial posts that we put in place. And so we then went on and built up posts around the rest of the perimeter of the property. So we just used 4x4 treated lumber around the whole thing. The straw wall is under this blue tarp here, and we're actually facing the front of the house just now from that side. So to make sure we sort of tied all this together, we put horizontal 2x4 sections of lumber between all of the vertical posts, and to get that level, you can just see there the plastic pipe that we used with some water in it, and that just allowed us to create a true level across the whole ring that we put in, connecting all these verticals together. So looking at the design of the roof, this isn't the actual roof truss design. It's just gives the idea of the aspect that we're wanting for the roof, which is an A-frame structure just sitting on top of the walls there. And we have a problem that the house by design isn't a symmetrical rectangle. Looking at a top-down view of the house, a plan view of the house, the back of the house is actually wider than the front, so you get this kind of asymmetrical view when you look at the top view of the house, and that's represented here on the drawing. So this would be the straw wall on the right hand side, and on the left side would be the cob wall. Again, this is facing the front of the house. And then you can see just these lighter shade projections coming out the side. So we wanted quite a shallow angle for the roof, just to sort of minimize the intrusion, just to keep it quite a small, low structure, and quite a long overhang at both the south and the north facing sides, just to keep water away from the wall. And we'll come on to that a little bit later. So to look at the strength of the roof, it really fundamentally comes down to the snow load in the region. So where we are, there we had to look at local ordinances, which are essentially the kind of local interpretation of the International Building Code. And in there, it defines what the expected snow load would be for the area, which is £60 per square foot that we should expect, and that's what we should be designing against. And so looking at the roof here, we would therefore expect £30 per square feet. We've calculated that the whole roof square footage is 560 square feet, which gives us a snow weight of 8.5 tons pushing down onto the roof. And that snow weight is therefore acting on the roof structure itself, which, as I say, is just represented here. So it's, pushing directly onto, it's affecting the roof structure, but also the, what it's sitting on, which is the vertical post structure that we've put in place, which will fundamentally hold the roof. So to make sure that was strong enough, we had a look at the strength rating capacity for the 4x4 beams that we used. They're roughly 10 feet high. Some of them are actually smaller, but we based it really on the worst case here. And so for each 4x4 column that we put in place, it's got a axial load compression of about 4,500 pounds. We have just over 20 vertical columns around the whole perimeter of the house, around the walls, and so that gives us a load capacity of about 47 tons of weight. So that would be the snow weight plus the weight of the roof and everything else pushing down onto these columns. And just based on the expected weight of the roof, the weight of the snow, we think we've got a safety factor of about 5 there, which is quite comfortable for this design. So now, with that information, we went on to design the actual roof trusses. So we have taken the design that we showed before, which had the overhangs on both south-facing and the north-facing sides. We actually cut the south-facing one a little bit shorter because we want to have more light able to come into the house from that side, but kept it longer at the back as previously described. And then we came up with this truss design. So the main horizontal base joist here of the roof truss is a 2x6, which is running horizontally left to right, and then we have two rafters, one in the south facing, one in the left, one on the right here, which are all 2x4s. All the rest of the wood here are 2x4s. We have webs, and then in the middle, running vertically here, is a king post, which is a 2x6 piece of timber there from that side. So this gave us the basic design. What these webs do is just provide additional strength, so it takes a lot of the pressure away from these main joints here. It assures that this whole thing stays as one more rigid structure, and the forces are all pushed down into the wall structure that we've built up already, and takes the weight of the roof without any deflection. So it's worth just looking at how we prepared the surface that this roof would sit onto. This is looking from the other side of the house, so this time the straw wall is on the left-hand side, obviously. These are our vertical beams. We trimmed these off. We had the connecting horizontal sections that we talked about before, and then on top of that, we laid this piece on top. And what this is are sort of framing structures with OSB board on one side, a simple frame of 2x4 on the top, and this would act as a sort of rigid kind of engineered piece, as a bond beam, we're terming it, that we can have lots of sections like that and put round the whole roof. This is just resting up here just now, that's why it's not very even just now. And then once that's nailed onto the roof, we then put a closing piece of OSB on top, which gives us the next picture here, which shows these all in place round the roof. And so you can see how that works. It gives us a a sort of flat structure attached into the frame below, and it gives a good surface to fix the roof trusses onto that. So getting onto the roof truss construction, we decided to build one as a prototype just at home, just to prove the design and make sure it looked aesthetically what we're looking for, and see if there were any issues and work out how we're going to actually build these things. So this was just a prototype, not really intended to be used for the final construction. So we've just bought the lumber from the local store, and also some hurricane straps, which are these sections shown up in the upper right here, and just experimented with these to see the best way of assembling this whole thing together. And for ease of transportation, we built it in two halves, and so this is just one half of a truss shown here. When we built two of them, took them back out to the plot, we attached the two together, as you can see here, to create one single truss, which sort of matches up with the design that we had done before. We added a couple of feet to it, hoisted it onto the roof, and that allowed us to move it from the front of the house to the back of the house, and just make sure that the overhang was okay. As I mentioned, the front of the house is slightly narrower from the back of the house, so we wanted to make sure that it was still going to sit properly on top of our bond beam, and look okay, and be suitable for what we're looking for. So we were quite pleased how that one turned out. And we then ordered wood from a local lumber merchant. We could have asked them to actually build the trusses for us, but it would have given us quite a problem just transporting them round the property. As I said, access is very limited, so it was easier just to to get the lumber delivered and then carry it up to the plot and assemble the trusses ourselves. So how we did that was we designed them in pairs. So we would build the two trusses just on the ground, then prop them up together and separated them with these separator pieces, which are just 2x4s, just to hold them the correct distance apart. We went for roughly 2 feet apart for the between each truss, and so we built these pairs as an easier way of handling the trusses before putting them onto the roof. This is the one that's for the front of the house. It's a little bit special. It's got an overhang, so we sort of built that onto it at this point. It was just easier to do it while it was all on the ground, and so that's what will hang over the front of the house and provide some rain protection there. Once we had this whole assembly built together, we started off using nails actually to nail all the separators and stuff in. Then we discovered screws was actually a much more reliable method. We don't need particular strength, so screws were good enough. And then we hoisted that onto the roof just using our backhoe as a simple crane. And then once it was on the roof, we were able to push it down the length of the house to the far side, as you can see here. And so that was pushed down to the far side, and then we built more truss pairs and just kept adding them on, just kept pushing the whole assembly further down the roof and screwing all these together with some more separators. And that was really how we built the roof frame. It was very simple. It was really just the two of us working. We used the backhoe as a simple hoist, as a crane really, to get this onto the roof in sections, and then as a sort of sheathing material just to sort of close off the roof, we just used OSB sheets that we simply nailed down onto the roof structure. So it's very simple, very straightforward design, capable of taking the snow load of the area, and all these vertical posts capable of holding the whole structure in place. And that was the design. As I say, there are other videos showing showing more details of how we assembled and put all this together and got it onto the roof, but this was really just to show the design aspects of it. So thank you very much for watching, and more links below of other videos.